Okay, guys, it should be Tuesday, and I want to work on a couple of worksheets with you to go practice some more area under curves between two curves. So you can listen, get the problems, write them out on paper, and then try them, and then you can come back and see if you got the right answer, kind of skip through my talk, and then if you didn't get it, you can go back and see what I did, okay? So first off, here's our two functions. We have an upside down parabola and a right side up parabola, and we want it between 2 and 4. So we kind of have to sketch them and get an idea where they intersect, if they intersect evenly or whatever. So if we graph it well enough, we might be able to tell without. So let's get the y-intercept the vertex for the first one. It would be the opposite of b over 2a, and so that would be -6 over -2, which is 3. And if you put 3 in, you get -9 plus 18 minus 3, so -12 plus 18 is 6. So 3, 6 would be the vertex of this one. So 1, 2, 3, 1, 2, 3, 4, 5, 6. So up here. Okay. And then it has a y-intercept of -3. So it has a point down here and up here. And the other one, and let's just bring it down over that way, is got opposite of b would be 6 over 2, so that's 3 again, and this is 3, and I think that'd be 9 minus 6 plus, 9 minus 18, which would be -9 plus 10, that would be 1, so 3, 1 would be right here, okay. Sorry, and then that hits the intercept at way up here at 10. Let's put 10 up here. So, kind of looks like that. And we want it from 2 to 4. So, it's going to be this inside. So, we know our interval is going to be from 2 to 4. And the top one would be your upside down, so that the top is -x squared plus 6x minus 3 minus x squared minus 6x plus 10, and put all that together, you got 2 to 4 of -2x squared plus 12x minus 13 dx, and so that would be, let's see, -2/3 x cubed plus 6x squared minus 13x from 2 to 4. Okay, so if you do the math for that, you should get 1 1/3, here's the work for it, minus -7 1/3, and you get 8 2/3. Now, look how nice this would be if you could just put it in your calculator. You wouldn't even have to simplify it. You could just stick that right into your calculator. But for now, we're still working them by hand, okay? Let's move on. Next one, let's see, what does this look like? Same thing, upside downside one. All right, let's take our calculator this time. We know that it's going to be, and we don't know where it is, but we know, I'm sketching it over here, that one is upside down and one is right side up, and we need these intersections because it doesn't give us an interval. It wants this. So it wants this piece right here, this colored in piece. So we're going to have to find those intersections. So just going to sketch it here and sketch it here and draw it out like that. I know that's sloppy. And then I'm going to look for that and look for that on my calculator. So I'm going to, my calculator, just graph y1 and y2 and look for the intersections. Let's you can try it on your regular calculator. Remember, you would do analyze. You would go to menu once you graph them both. But I haven't showed you how to do that, so just use your TI-84. You know how to do it, and then I'll show you how to do this on your new one when I get back. So, okay, so when I took my calculator, I got, this point was 1.419 at 3.5, and this one was 4.581 at 3.5. So our integral becomes, from 1.419 to 4.581 and the top one is the negative one, so negative x squared plus 6x minus 3, and then minus x squared minus 6x plus 10, the whole thing dx. So let's just put that in the calc, all right, and come back and see what you get. Okay, I got 10.541. If I punch everything in right. If I didn't, you have the general idea, okay? So let's move on.